The largest predator ever to hunt in the ocean did not stalk fish. It stalked whales, snapping through blubber and bone the way a person might bite into an apple. A single tooth from its mouth could cover the palm of your hand. For millions of years, nothing in the sea dared challenge it. Its name is Megalodon, and this is its story. Every shark alive today can trace its family tree back through millions of years, but Megalodon belongs to a branch that split off long before any of them existed. Scientists once called it Carcharodon megalodon and treated it as a giant cousin of the great white shark because the two animals share the same triangular serrated teeth. That link has since been cut. Megalodon actually belongs to a completely different family called Odontodidae, one that separated from the great white shark's ancestors deep in the age of dinosaurs. Along the way, it has worn other scientific names too, including Carcharicles megalodon, before most experts settled on its current genus, Otodus. The resemblance between its teeth and a great white's is not shared family history. It is two unrelated hunters independently arriving at the same winning design, a pattern biologists call convergent evolution. Megalodon patrolled the world's oceans from roughly 23 million years ago to about 3.5 million years ago, a run of time so long it makes the entire history of our own species look brief by comparison. Fossilized teeth have turned up on every continent except Antarctica, from the coasts of the Americas to Europe, Africa, Australia, and Japan. Wherever the water stayed warm and prey gathered close to shore, Megalodon was likely there, and shallow coastal seas and river mouths acted like highways connecting one hunting ground to the next, letting a single species dominate oceans separated by entire continents. Unlike a shark's cartilage skeleton, its teeth were made of dense, mineral-rich material that resists decay for millions of years, which is why they survived in such enormous numbers while the rest of the body rotted away long before it could ever turn to stone. For most of human history, nobody knew what these fossils actually were. As far back as ancient Rome, the naturalist Pliny the Elder wrote that these strange triangular stones fell from the sky during lunar eclipses. Later, across medieval Europe, people believed the same stones were the petrified tongues of dragons and serpents. That myth finally broke in 1667 when a Danish scientist named Nicolas Steno dissected the head of a large shark and noticed something the tongue stone believers had missed. The stones were teeth. In 1843, the naturalist Louis Agassiz gave the animal its formal scientific name, built from Greek words meaning simply big tooth. He was comparing hundreds of fossil teeth gathered from collections across Europe rather than working from one spectacular find, and that comparison convinced him he was looking at something entirely new to science. But naming a fossil and understanding the animal behind it are two different things, and for a creature this size, that gap still is not fully closed today, because for all its size, Megalodon eventually disappeared, and working out why turns out to be one of the hardest puzzles in the history of the ocean. Reconstructing what Megalodon actually looked like runs into a problem most dinosaur scientists never have to deal with. Sharks do not have bone skeletons. Their skeletons are made of cartilage, a softer tissue that almost never survives the fossilization process. What we have instead is a scattering of teeth by the thousands, a handful of preserved vertebrae, and almost nothing else. Every reconstruction is built by comparing that limited evidence to living sharks and asking which body plan fits best. For decades, the assumed answer was a scaled-up great white shark, thick-bodied and bulky. A major reassessment published in 2025 challenged that picture directly. Rather than relying on teeth at all, it measured vertebral proportions preserved in a handful of fossil spines and compared them against more than 160 living and extinct shark species to estimate what shape of body those proportions would need to support. Megalodon's body length is still debated, with that same reassessment suggesting the largest individuals could have reached around 24 meters or about 80 feet nose to tail. A shark that size may have weighed somewhere close to 94 tons, roughly the same as 20 adult African elephants standing on one scale. That same study reshaped more than just the numbers. It argued Megalodon's body was more slender and torpedo-shaped than the old, bulky reconstruction, closer in proportion to a lemon shark than to a great white shark built for efficient, sustained cruising rather than short bursts of speed. Researchers estimate a comfortable cruising speed of only 2 to 3.5 kilometers per hour, a gentle pace built for covering enormous distances rather than winning a sprint. A slimmer, faster cruising body also fits with something else scientists have proposed about Megalodon's physiology, evidence that it may have kept parts of its body warmer than the surrounding seawater, a trait called regional endothermy. That warmth would have powered stronger, more sustained swimming than a cold-blooded shark could manage, but at a steep cost, since a warm body burns through calories far faster than a cold one. The one feature every reconstruction agrees on is the mouth. A megalodon jaw could open wide enough to swallow 2 adult humans standing side by side, lined with rows of teeth built to slice through flesh and crack bone in the same bite. Each tooth was broad, triangular, and edged with fine serrations, some growing past 18 centimeters or about 7 inches along the slanted side, roughly the size of a human hand. Like all sharks, Megalodon never stopped growing new teeth, with rows behind the working row moving forward to replace any tooth that broke or wore down, so a single animal could shed and regrow tens of thousands of teeth in a lifetime. That biology explains something museum visitors often find strange. Megalodon fossils are almost never bones. They are teeth, because teeth were the one part of this shark tough enough and produced in numbers large enough to survive 20 million years underground. Megalodon also relied on senses no fossil can show. Its snout was covered in tiny jelly-filled pores called the ampullae of Lorenzini, able to detect the faint electrical pulse of a living muscle nearby, revealing a hiding whale calf before the shark ever saw it. A tall, crescent-shaped tail fin and a pair of pectoral fins nearly as long as a small car worked together to drive that slender body through open water with barely any wasted effort. Step back onto a Miocene coastline, and the ocean looks almost unrecognizable. Enormous baleen whales, many smaller and slower than the giants alive today, graze through nutrient-rich shallow seas alongside early dolphins, huge sea turtles, and other sharks working the same warm coastal waters. It was a world built on abundance. Warm water packed with food from the surface down to the sea floor. For an animal built on the scale of Megalodon, that abundance was not optional. It was the entire reason the animal could exist at all. Megalodon's main prey were whales, and the fossil evidence for that is unusually direct. Whale bones recovered from Miocene deposits carry deep gouges and puncture marks that match the size and spacing of Megalodon teeth exactly, some cutting straight through solid bone rather than just scarring the surface. Some individual whale fossils carry more than 100 separate tooth marks, evidence of repeated, sustained attacks rather than one single strike, and a reminder that even an ambush this powerful sometimes needed more than one bite to finish the job. Many researchers think Megalodon targeted the chest and flippers of its prey first, crippling a whale's ability to swim before delivering a killing bite, a pattern quite different from a great white shark's usual strike toward the belly. Dolphins, seals, large fish, and smaller whales rounded out the rest of the menu. An animal moving at Megalodon's scale needed a genuinely enormous number of calories every single day just to keep its body running. That last point turns out to matter more than it first appears. Chemical evidence locked inside fossil teeth in the form of zinc isotopes suggests Megalodon sat at the very top of its food web with almost nothing above it. An apex predator in the fullest sense of the word. Very few animals ever reach a position like that, with nothing left above them and everything else adjusting around their presence, and Megalodon appears to have held that position for almost the entire span of its existence. Some fossil evidence even points to Megalodon attacking members of its own species, likely targeting the young, which would make cannibalism part of its ecology alongside whale hunting. A predator that dominant, with a diet that demanding, should have been secure for as long as its prey remained abundant. The most recent fossil evidence places Megalodon's disappearance at around 3.6 million years ago during the early Pliocene, a date pulled back from an older estimate closer to 2.6 million years as new specimens were studied. Earlier researchers had leaned on a smaller set of fossil sites, and the revised older figure came from expanding that dataset and, more carefully, excluding fossils whose exact age could not be confirmed. Across that same stretch of time, roughly a third of all large marine animal genera disappeared with it, whales, seals, seabirds, and sea turtles among them, in one of the more severe extinction events the ocean has ever experienced. Losing the largest predator in the sea was not an isolated tragedy. It was one casualty inside a much larger collapse, one thread pulled from an ocean-wide web that was already unraveling on its own, whale by whale and shoreline by shoreline. No single explanation fully accounts for what happened, and researchers studying the extinction generally point to several overlapping causes rather than one clean answer. Global ocean cooling during the Pliocene shrank the warm, shallow coastal seas Megalodon depended on for hunting and for raising its young, and sea levels dropped as ice sheets grew, squeezing those habitats even further at exactly the wrong moment. At the same time, many of the large whale species Megalodon hunted were declining or shifting into colder waters that its warm-bodied metabolism could not easily follow. And a new competitor had entered the scene. The great white shark had evolved its own serrated teeth only 5 to 6 million years earlier, and by around 4 million years ago, had spread into nearly every ocean Megalodon still called home, arriving with a smaller body, lower food requirements, and no need for the same enormous daily catch to survive. No fossil is marked as the last one. No headline announced it. No final witness ever came forward, and no single storm or season could be blamed. There is no single fin that vanished beneath a wave with anyone watching, no final tooth that fell to the seafloor knowing it would be the final tooth. The largest predator the ocean had ever produced simply grew rarer across a few 100,000 years, one missing generation at a time, until the seas that had carried it for 20 million years carried it no more. Whales kept swimming through those same warm coastal shallows. Great white sharks kept hunting. The ocean did not pause to mark what had just been lost. It simply moved on the way it always has, leaving behind nothing but teeth scattered across the seafloor, waiting millions of years for something clever enough to wonder what they once belonged to. Now for my favorite part, a few fun facts your friends probably don't know. Megalodon babies were already dangerous before they took a single breath of seawater. Fossil evidence suggests that inside the womb, the strongest embryos ate their weaker, unhatched siblings, a survival strategy scientists call intrauterine cannibalism, so that only the toughest pups were ever born. Even by shark standards, that is a violent start to life, and it may explain why the litters stayed small. Those survivors arrived already bigger than a fully grown great white shark, ready to hunt from the moment they entered the ocean. Megalodon's mouth, meanwhile, held a surprise of its own. Some fossil jaws show more than 200 teeth arranged across several rows at once, with thousands more replacements waiting in reserve throughout its life. Fossil hunters still find Megalodon teeth today, not only buried in rock, but scattered across the seafloor. Divers regularly recover them off the coast of the southeastern United States, the teeth often stained black or gray after millions of years of mineral replacement. A single well-preserved specimen can sell for hundreds, sometimes thousands of dollars among collectors, and despite decades of documentaries and internet rumors claiming otherwise, no credible scientific evidence suggests Megalodon is still alive somewhere in the deep ocean today. The fossil record closes firmly around 3.6 million years ago, and nothing discovered since has reopened it. I hope that one surprised you as much as it surprised me. Let me know in the comments which extinct animal you want to see here next, and if you learned something new today, a like and a subscribe genuinely helps this channel keep going. And until then, stay curious. Thanks for watching, watch this video next, and subscribe for more.